Okay, we're going to look at special cases here for when we're factoring, and this one is the difference of squares. So anytime I see a binomial where we have a subtraction sign is here, the next thing I'm checking for is, are both of these terms square terms? So what does that mean? Well, if I look at 4x squared, I know that 4 is a square number. I can do that as 2 times 2. And x squared is also going to be a square because it's x times x. So I could actually write this as 2x all squared. And if I multiply 2x by 2x, I would get 4x squared. So that's a square term. And then we know that 25 is just 5 squared. So both of these are squares. And we can have a shortcut for factoring a difference of squares situation. So we can think about this actually as 4x squared plus 0x minus 25. And if you wanted to think about it that way, you could do decomposition and it would work. You'd look for two numbers that multiply together to get minus a times c, which is 100, and then they'd have to add together to get 0, which means it would be the factors would be the same. So you'd have a plus 10 and minus 10x term that you would decompose the middle out, and then when you factor by decomposition, it will work. However, if it's a difference of squares situation, we can actually come up with a shortcut. So what's our shortcut going to look like? All we have to do is take the square root of the first term, which is going to be 2x, and the square root of the second term, which is 5, and we set up a scenario like this. Now, in terms of our signs, well, we know if we have a negative product on the end that one of them has to be positive and one of them has to be negative. And if you were to expand this out and work backwards, you would end up with 4x squared plus, so 2x times minus 5 would be minus 10x. Positive 5 times 2x would be plus 10x, and then 5 times negative 5 is minus 25, and you would have these two middle terms here, 0 property out, to get us that 0x. So this does work, and it's going to be that way for all of our difference of squares examples, in that we just take the square root of the first term, square root of the second term, we're multiplying them together, and we have to have different signs here. This second example that we're going to look at is a bit more challenging, a bit more tricky. So we're going to shrink it here so I can get enough page to work with. Let's undo that. All right, so at first glance, I see two terms, they're being subtracted, so I'm kind of thinking, is this a difference of squares example? But I am looking for that common factor every single time. So in this case, I see a 5 is going to be common to both, so I can factor out a 5. When I take a 5 out, what I'm left with is x exponent 4, take away 16y exponent 4. Any variable raised to an exponent that's an even number is technically a square. So for example, x exponent 6, I could write that as x cubed times itself, which would just be x cubed squared. In this case, it's going to be x squared squared. So if I think about our shortcut for doing difference of squares, I have two brackets. One has a positive in the middle, one has a negative in the middle, or a subtraction sign. The square root of that first term is x squared. The square root of the second term is going to be, well, square root of 16 is 4, and the square root of y exponent 4 is going to be y squared. So I have the same thing in the other set of brackets, except it's just the negative version of that. Now, So that there is pretty well factored. However, we now have another example that is a difference of squares, and this is where it's kind of, throwing us for a loop here, a little bit extra of a tricky step on the end. So I can now factor this even more. So this is not fully factored. So I'm going to write the 5. I have x squared plus 4y squared here still. And then difference of squares again. I can write x squared as x times x. I can write 4y squared as 2y times 2y. And in order to make it so that that middle term would cancel out, I would have to have a positive and a negative here. So that's a trickier example of a difference of squares situation. We're going to give you one to try that's very similar to these two. So if you look over here, pause the video, and these two examples here should be pretty similar for you to try. Alright, so we're going to quickly go through these. So first example, I see that in question A, we've got a 81. I know 81 is a perfect square. And I see 49. 49 is a perfect square. And then I've got that m squared term. So I'm pretty confident that we're looking at a difference of squares. 81m squared I can write as 9m times 9m. Square root of 81 is 9. Square root of m squared would be m. 49, square root of 49 is 7. And it's a difference of squares situation. I need that middle term to cancel out. We also need to have a product of negative 49, so we need a positive version and a negative version. So that's fully factored there for question A. Question B, a little bit trickier. I see that I can rewrite B. I see a 2 is common here. So I can rewrite this as 2 times 162 divided by 2 is going to be 81 if I factor out a 2. And I'm going to have the v exponent 4 still there, and then I have minus w exponent 4. So this line here is equal to this. All I've done is factor out a 2, and now I have an example of difference of squares in here. So I'm going to put my 2 still there. Do not lose that 2 along the way. Every line has to be equal to the previous one. And now I'm going to do difference of squares. Move my screen down. So square root of 81 is going to be 9. So I have a 9 here and a 9 here. Square root of v exponent 4 is going to be v squared. Square root of w exponent 4 is going to be w squared. And once again, I can always expand these out to make sure w squared times w squared. But I need it to be negative. So I'm going to put a positive version and a negative version. It does not matter order in terms of these two things. You can rearrange them because multiplication is commutative. And once again, I'm not finished because I have another example of a polynomial that can be factored here. Another example of the difference of squares. So I'm going to have the 2. I'm going to write in this 9v squared plus w squared term. That cannot be factored. However, this one can. Square root of 9 is 3. Square root of v squared is v. Square root of w squared is w. And then I need the positive and the negative version of that.